A journey beyond the stars. Carbon is the backbone of life as we know it. From the DNA in your cells to the carbon dioxide you exhale, this element is essential for every living organism on Earth. But have you ever wondered where this life-giving carbon comes from? Could it be that the very essence of life originated not on Earth, not even in our solar system, but from distant corners of the cosmos, perhaps even outside our galaxy? Today, let's embark on a journey through time and space to explore the evidence and theories about the extraterrestrial origins of carbon, the element that connects us to the universe itself. Carbon is formed in the hearts of stars through a process known as stellar nucleosynthesis. When stars age and reach the end of their life cycle, they release carbon and other elements into space through massive explosions called supernovae or through gentle stellar winds. These cosmic events scatter the stars, ashes, across the galaxy, seeding future generations of stars, planets, and potentially life. But is all the carbon we find on Earth native to our galaxy, the Milky Way, or could some of it have come from even farther away? Intergalactic dust carried by cosmic winds. Astrophysicists have discovered that intergalactic space isn't entirely empty. It's filled with clouds of gas, dust, and other particles, including carbon-rich compounds. Galactic winds, generated by powerful quasars and supernovae, can propel these particles across immense distances, sometimes even between galaxies. Some of this material could have eventually been incorporated into our solar system during its formation billions of years ago. Carbon in meteorites, a clue from the stars. Meteorites that have fallen to Earth are like time capsules, preserving material from the early solar system. Studies of certain meteorites, such as carbonaceous chondrites, reveal the presence of organic compounds and isotopic ratios that hint at an origin beyond our galaxy. These meteorites may have been formed from material that traveled vast distances before becoming part of the solar system. The isotopic fingerprint. One of the strongest pieces of evidence comes from studying isotopes of carbon. Some isotopes, like carbon-13, are more abundant in certain regions of space. By analyzing the isotopic ratios in ancient rocks, meteorites, and interstellar dust, scientists can trace their origins. In some cases, these ratios suggest that the carbon we find on Earth may have traveled from other parts of the Milky Way, or even from neighboring galaxies like Andromeda. The idea that life on Earth, or at least the building blocks of life, may have originated in space is known as panspermia. This hypothesis suggests that organic molecules, including carbon-based compounds, hitched a ride to Earth on comets, asteroids, or interstellar dust. If true, this means that the carbon in your body could have been forged in a distant star, traveled across the galaxy, and eventually found its way to Earth billions of years ago. Recent discoveries, such as amino acids and other organic molecules on comets like 67 P/Churyumov-Gerasimenko, and in the icy moons of Jupiter and Saturn, strengthen this hypothesis. These molecules are the precursors to life, suggesting that the building blocks of life are widespread across the universe. While most carbon on Earth likely originated in the Milky Way, there's a tantalizing possibility that some of it could have come from even farther away. The universe is a dynamic, interconnected web of matter and energy. During the early stages of the universe, galaxies were closer together, and material could have exchanged more freely. Intergalactic collisions and the transfer of matter through cosmic winds might have brought carbon-rich material from other galaxies into the Milky Way. Renowned astrophysicist Carl Sagan famously said, "We are made of star stuff." This poetic statement underscores the profound connection between life on Earth and the cosmos. Whether the carbon in our bodies came from a nearby star or a galaxy billions of light years away, it reminds us of our shared heritage with the universe. The story of carbon is the story of life itself. From the fiery hearts of ancient stars to the vibrant ecosystems of Earth, carbon has traveled an extraordinary journey through space and time. While we may never fully unravel the mysteries of its origins, the evidence suggests that life's most essential element is as ancient and cosmic as the universe itself. So, the next time you marvel at the stars, Remember that you carry a piece of them within you, a timeless legacy of the universe's creativity and vastness. If you enjoyed this deep dive into the cosmic origins of carbon, don't forget to like, share, and subscribe to our channel for more explorations of science, space, and the mysteries of existence. Let's keep looking up and asking the big questions, because the answers might just change the way we see the universe and ourselves.